Hello student, good morning. Today we are taking the new topic heating effect of current. Student, we learned in the previous class the current is given by I is equal to V upon R, and we also know the current is also equal to Q upon T. It is observed when the current is flowing through the circuit, it will produce heat around the path where it is flowing. This is first observed by Joule, so this is called Joule's heating effect. This is a very important topic for 10th class because it is asked every time by the board exam. So we need to understood about the heating effect, how its formula is determined, and also it is important to understood the laws of heating effect. Now first we derive the formula for the heat produced when current is flowing inside the circuit. Okay. Suppose we have heating effect of current. Okay, the topic is heating effect of current. Suppose we have a simple circuit having a resistor connected with a source of potential difference V volt. When the circuit is complete, the current I is flowing through the battery due to the resistance R. Then it is observed when the current is passing through point A to B, due to this resistance fire, the heat produced by the current is more. This heat we calculate like this. Consider a circuit. Consider a circuit having resistance R connected with a potential difference V, connected with a potential difference V. Let I current flowing through resistor R, from point A to B. Therefore, work done to to carrying Q charge from between point A to B is given by W is equal to VQ. Student, we have potential difference is equal to W upon Q. We are using this result from here. Okay. Now we have we know that the value of Q is equal to I into T, and according to Ohm's law we have V is equal to I into R. These are the two equations. Okay. Now on putting Q and V in work done, we get W is equal to, in place of V we are putting here IR, and in place of Q we are putting, that is, I into T. Now student, this I multiply with I and become I square RT. So the work done moving the charge from point A to B across a resistor R is given by I square RT. This is the work done. This work done stored in register as heat energy, and the heat produced is given by H is equal to W upon J, where J is Joules heating constant. Joules heating constant. Okay student, now on putting the value W in H, we are getting I square RT upon J. For SI system, J is equal to 1 unit. Therefore, heat produced in the resistor wire is I square RT. So student, this is the Joules heating effect. Just copy this whole derivation. Okay student, now we are going for rules of heating effect. Now students, because the heat observed in the wire is first by Joule, so it is also known as Joule's heating effect. Joule given some rules how the heat is produced inside the conductor, and we also remember this as the effect on heat produced in the conductor, dependency of heat production. That is, according to Joule, when current passing through a resistance wire heat is produced, produces in the wire. This heat, this production of heat in the wire is depends on the following factors. First, heat is directly proportional to square of the current flowing in the conductor, or wire. That is, this heat is directly proportional to the I square. This is equation first. Second rule is heat is directly proportional to resistance of conductor. That is, heat is directly proportional to the resistance. This is your equation second and rule second of Joules. And third point is heat is directly proportional to time. That is, heat is proportional to time t. This is rule third. Okay, on combining all three rules, above three rules, we get heat is proportional to I square RT. Okay, on eliminating this proportional to sign, we are getting heat is I square R T upon J, where J is joules heating constant. Okay, and J is equal to 1 unit for SI system. Therefore, the heat produced is equal to H is equal to I square RT. This is the Joules heating rule, or heat produced or heat developed inside the conductor when current is flowing. These are the three rules given by Joules. So it is called Joules heating effect, and this J is equal to Joules heating constant, and the value of J in SI system is 1 unit, so result is become H is equal to I square RT. Now student, it is very clear, when we increase the current, the heat is increased the square of the value as current increased. Similarly, if we increase the value of resistance, the heat is again increased linearly as the same value of resistance increased. And here the heat is also increased as the same value as we use the device that much of time. Copy this rule. In the next class, we are discussing about the application of heating effect of Joule. We have three applications. One is electric bulb. Second is heating effect of current as electric heater. Next, we discussing about the fuse or fuse wire, electric fuse, in which we discussing about the nature of the material which is used in making fuse and is used in making an electric heater or electric bulb. Basically, we are going to understand which kind of the material is used to making the filament of bulb, the heating element and the fuse wire. Thank you, student.